Traditional plaster of Paris casts are still used, especially for their malleability and molding to the bone, but fiberglass and other composites are now more common. Composite materials, such as fiberglass and newer 3D printed polymers, are used to create casts for fractured bones to immobilize the break for healing. Fiberglass casts are lighter, stronger, and come in colors, while 3D printed casts can be customized, are waterproof, and may distribute force more evenly. This presentation introduces the new cast materials used in bone fractures. Broken bones are cured through application of casts. Normally, plaster of Paris casts have been most widely used throughout the world. Innovations in medical industry has resulted in the introduction of new casting materials. One of them is the fiberglass cast, made up of pre-pregs, which cure after wetting, while applying it on the fractured limb. The most recent introduction is the use of additive manufacturing technique to produce lightweight and durable polymeric cast structures. All the three types have been briefly explained in this lecture. Plaster of Paris is the traditional cast material. It is made from calcium sulfate and starch, which hardens when mixed with water. These are malleable, easy to mold to the shape of a limb. These are very cost-effective. However, these are heavy and prone to damage from moisture. Fiberglass is modern cast material that is more durable and lighter than traditional plaster. Modern casting tapes increasingly rely on synthetic composites using polyester or polypropylene fabrics combined with water-activated polyurethane resins. Being lightweight, strong, and porous, allows for more air circulation and comfort. These are not easily molded where complex contours are present. 3D printed polymer cast is newer technology that creates custom-fit casts, often with a lattice-like structure. 3D printed polylactic acid, PLA, and PLA, calcium carbonate composite splints for fracture management. The 3D printed materials generally have better mechanical properties than the traditional casts in terms of tensile and flexural strength, which means they could potentially be made thinner while maintaining strength. These can be converted into customizable designs and are waterproof and allow for air circulation. This is newer technology and less widely used than traditional materials. Doctor chooses the best material for fracture based on its location, severity, and the need for stabilization. The choice is made out of the three categories. Plaster cast is best for complex fractures. Fiberglass casts are lightweight and strong. 3D printed casts are waterproof and light in weight. Plaster is generally cheaper than fiberglass, but newer materials may not be covered by insurance. Fiberglass casts are more durable and less prone to breakage than plaster. However, these are not waterproof, but some modern materials and 3D printed designs are water-resistant or waterproof. An important advice is: never remove a cast yourself. You may cause further injury or prevent proper healing. New trends in fashion have emerged in casts as well. Instead of wrapping messy plaster or fiberglass, open lattice net is feasible with resin avoiding processing issues and wait times. It allows you to get back to life better and faster. Braces, supports, and guards protect vulnerable joints including knees, elbows, and wrists. Ankle braces stabilize the ankle while permitting natural flexion mobility. Knee braces provide lateral support and reduce friction. Stay tuned to get yourself acquainted to new topics in the field of composites manufacturing. Technology Education and Mentoring Center stands committed to its aim of popularizing the field of fiber-reinforced composites that has found numerous applications in all fields of human life.